you need to know how to predict signal multiplicity in NMR if you're going to pass organic chemistry too. And honestly, it's not that hard. So what we do is we look at the neighboring protons, okay? And we use this formula right here, which is your general formula, where the signal multiplicity is equal to n plus 1, where n is the number of neighboring hydrogens that are non-equivalent. We can go through some examples now. Now this is known as vicinal coupling, because we're looking at protons here, coupling to ones here, and vice versa. And that's usually in the 6 to 8 hertz range, okay? So this would be all roughly 6 to 8 hertz apart, and that's why they give us these nice splitting trees. So if we look here, there is an internal plane of symmetry right here, which makes these identical right here. So if we look at the multiplicity of this, it doesn't see this, so to speak, so it doesn't couple to this because it's the same. It just sees itself. However, there are 3 neighboring protons right here that are different, and so it sees them. We use our formula where n plus 1 equals our multiplicity. This would, you'd see a quartet where it would look like this. And similar here, we see 2 protons next to it, where so n is 2, we'd see a triplet. So we'd see a triplet like this, where we, like that. Now, let's start getting a little more complex. We already know what this is right here. This would be our triplet again, and then this would be our pentet actually, because there's 3 here, now there's 1 over here. That's 4 now. Now this is where it gets a little interesting. So this one proton right here, it has 2 neighbors here, it has 3 neighbors here, and 3 neighbors here. That's 8. So it's going to be a non-et, and that's going to look like a whole big old mess. Now, these 2 right here, these are identical. So they will be the same signal. However, they only each see 1 other proton right here. So these would be singlets. All right? Now, again, we have our triplet here. And now we're back to a quartet. Well, why is that? Because there's 3 here, but because we have this tert-butyl group, there's no protons there. And similarly, all of these methyl groups are identical. They're going to be 1 signal, and none of them see another proton because there's no other proton here. So these will all be singles. Oh, I'm sorry, up here, this is not a single, this is a doublet. These will all be singlets. So this would be doublets, and these look like this. Your singlet is just, okay? So, NMR, remember this.